Okay, hello everyone. I welcomes to all in our lecture series on laser physics. In this lecture series, we are discussing these topics which are most essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. In our previous classes, we already discussed up to this much. Important numericals on laser and Einstein coefficient A and B. Last class we discussed important numericals. In this class, we are going to start to discuss laser sources. First, we are going to discuss Ruby ledger construction, working and its application. Okay, so let us start here. Ruby ledger, it is a three-level ledger system. See this question, if it will asked in your exam, it will asked for 3 to 4 mark. Whatever I am going to discuss in this class, it is enough for your exam that you have to write and you are going to get the full mark. Okay, here a Ruby ledger is a solid state ledger. This is first developed by Myman in 1960, and this was the first ledger in the world itself. The active material in the Ruby ledger is the chromium. The Ruby ledger produces visible light of deep red color having wavelength 694.3 nanometer. Okay, so this is the construction part. Here, this figure represents the experimental arrangement or construction of Ruby ledger. A Ruby ledger consists of three important elements. One is your laser medium, second is your pumping source, and third is your optical resonator. First, we are going to discuss about laser medium or gaining medium. In a Ruby ledger, a single crystal ruby, that is your Al2O3 aluminum oxide, doped with a small percentage of chromium oxide. The chromium percentage is your 0.05 percentage only. For laser action, the ruby rod, generally pink color, this is your ruby rod, okay, has the dimension of 4 centimeter length and 0.5 centimeter diameter. Pumping source, in this case, the pumping source used a xenon flash lamp. In a ruby laser provides energy to the laser medium. So this wire which is wrapped over this box, this one is your xenon discharge tube or xenon flash lamp. Optical resonator. In general, optical resonator is the arrangement of mirrors like this, arrangement of two mirrors or other optical elements that form a cavity resonator which can confine the electromagnetic waves or light by reflecting them back and forth for light waves. Resonator for light waves, but what is exactly, suppose this is the two mirror, in between that light will be reflected back and forth and it will confines the electromagnetic waves or light waves. In this case, in this ruby ledger, ruby rod is placed in between the two mirror. Here, this is the ruby rod, pink color. Its length is your 4 centimeter around, and its diameter or width, you can say, is your 0.5 centimeter. This will be kept between two mirrors. This is one mirror, this is another mirror, having optical coating. At one end of the rod, the mirror is fully silvered. This mirror, you can see fully silvered mirror, or you can write fully reflecting end. And another end, the mirror is partially silvered. Here, this is a partially silver mirror, or you can write partially reflecting end. The fully silvered mirror will completely reflect the light, whereas the partially silvered mirror will reflect most of the part of the light but allow a portion of the light to pass out as output laser light. So as it is partially silvered, so half portion will be reflected back into the ruby rod and another half portion will be come out from this instrument as a laser light. And this arrangement of these two mirrors provide a cavity resonator. So this whole arrangement is nothing but your cavity resonator. Here I am going to shortly explain this diagram. This is your ruby laser, ruby rod. That means Al2O3 single crystal having 0.5% only doped with chromium, so its color is a pink. This rod kept in between the two mirrors, one is fully silvered or fully reflecting and another is your partially reflecting, and this ruby rod is kept inside a vacuum tube. This is a vacuum chamber. Okay, here I written somewhere glass tube or a vacuum glass tube. The xenon were wrapped over this glass tube, or xenon flash lamp or discharge tube wrapped over this glass tube connected to the electric source. The when electric source will be connected, this lamp or xenon lamp will be flashed and provide the light energy to the ruby rod, and the chromium atom inside the ruby rod, the chromium atom will be activated and it will be provide the laser action. So how the laser action or laser oscillation will be found, that we are going to discuss in your working part. In the working part, here you can see the pumping of chromium ions is performed with the help of a flash lamp or xenon or krypton flash lamp. Here flash lamp used either xenon or krypton, and the chromium ions Cr3 plus in the ground state absorb radiation around wavelengths 5500 angstrom or 4000 angstrom and excited to energy level E1 and E2. So here the chromium atoms which are at the ground state, they will activate by this xenon flash lamp and moved to either this level and this level. So this chromium atom have capacity can absorb this wavelength or this wavelength energy. So if it will absorb this wavelength 5500 angstrom, then it will move to E1 energy level. If it will accept or ignite through this wavelength 4000 angstrom, then it will be activated or excited to the E2 level. Okay. Then the chromium ions excited to these levels relax rapidly through a non-radiative transition in time 10 to the minus 8 second. 10 to the minus 8 second, and this is nothing but your so-called spontaneous emission or spontaneous transition. That is your natural transition, already we have been discussed. So here chromium atom suddenly relaxed by a non-radiative transition after 10 to the minus 8 seconds. So these are the upper level. So chromium atom will be stay in this upper level for 10 to the power minus 8 second, and it will come down to another state, that is your metastable state. So this is the metastable state M, and after sometimes means after exactly 10 to the minus 8 second, chromium atoms which are excited to E2 and E1, they will be relaxed or come down to metastable state, which is named as M, by a non-radiative transition. The metastable state having the lifetime is 3 millisecond. That means very large lifetime as compared with this one. So the chromium atom will be stay longer time in this uh, level. See here you can see the two levels. It is closely degenerated. So many books it has been represented by one level, or many books it has been represented by two levels. So no issue, you can put as a one level here, only one level. So some books consider the degenerate case, that means in this level slightly degenerated by two levels, no issue. So chromium atom will be here or here, there is no problem. Okay, so chromium atoms will be come down to this metastable state and stay for the longer time, because this metastable state has the lifetime is 3 millisecond, which is very large as compared with this one. If it is so, then automatically population inversion will be created in between these two levels. If a population inversion created, that means it is ready to give the laser action, or we can say it is active state. So here the same thing it has been written, that a metastable state with the longer lifetime, with a lifetime 3 millisecond, laser emission occurs between M and ground state at an output wavelength around 694.3 nanometers. So here in between this M and G, a population inverse will be created and laser action will be takes place in between M and G. So this transition, due to this transition, whatever the light will be come out, that wavelength will be 694.3 nanometer or 6943 angstrom, and this will be the laser oscillation or laser emission by this instrument. So this is the working principle of the Ruby laser. So these are the applications of Ruby laser. It is applied for holography, okay, tattoo and hair removal, diamond drilling, laser range finder, high speed photography. So these are the uh, most important applications for Ruby laser. Okay. So thank you so much for watching this video. In our next class, we are going to discuss neodymium doped yttrium aluminum garnet laser or NdYAG laser. Okay. Thank you so much for watching this video. Thank you.